Hi, Edward. How are you doing?
Hi, good. How are you?
Good, good. So today I would like to discuss another topic which is quite interesting as well. It's the Amazon EKS Extended Support. So basically, in the past, as many of us know, handling and supporting Kubernetes is not always that easy because of the busy release schedule. We will show later on the release schedule and the supported versions currently in AWS. But I think it's an interesting point to cover because it's quite substantial actually, because whenever your cluster goes into extended support, it goes from 10 cents to 60 cents per hour. Obviously, this will give a lot of organizations financial incentive to actually follow a release schedule and not be like, I'm just going to install this and yeah, take my hands off it and hope that it keeps running forever. But I can understand that, especially in bigger organizations, if you look at the release schedule of, for example, Microsoft products or something like that, and you go from version 2010 to 2018, for example, like sometimes they take decades for organizations to actually maintain their infrastructure. So let alone to change that to months, which kind of makes sense because like if you would do the same thing and you would have like years and years of Kubernetes versions that you have to support, like it's not realistically that you can do that at that price point of 10 cents per cluster per hour. So in that sense, it makes sense that they force people to actually spend some time and upgrading their Kubernetes clusters. The only downside, obviously, is that it involves a lot of testing. It's not just like clicking upgrade and hope that it just all works. So and then it comes down to like that you have to have a lot of resources as well that will be actually maintaining it. And then if you look at, for example, other services like ECS Fargate, for example, like the yeah, it feels like a no-brainer, especially if it's just like for scheduling containers to then basically choose another technology that doesn't enforce you to do this. If you look at some clients of ours that are running ECS Fargate, like it just keeps working. Sometimes they have to like be rescheduled for a minor upgrade of the Fargate version, but it's no way near as labor intensive as following this release schedule, in my opinion. So, nevertheless, there are some good use cases that use Kubernetes. But yeah, maybe we can go through the announcement and then see from there.
Yeah, so I'll share my screen.
Awesome.
Yeah, so January 16th, 2024, they actually announced the pricing. They already said we're gonna extend the support. So it starts with 12 to 14 months, 14 months on AWS, where they support it by default. Just you pay 10 cents. You can run it for a little bit more than a year. In the past, you would then have to upgrade, right? So in the past, then it would become end of life,
Yeah,
and then you
exactly.
would have to upgrade. And actually, there are three minor version upgrades per year. So there are the Kubernetes team is releasing three versions a year. So there is all, and you have to also, when you upgrade, you have to follow the upgrades. You cannot go from one minor version and plus two minor version. You have to go to plus one. So it's already difficult to follow it, even if you just don't upgrade for a year. So now you can indeed stay longer, right? Pay this price, 60 cents per hour per cluster. So if you have 60 clusters, so if you have like 10 clusters, it's $6 per hour. So it's like 4 or 5 thousand a month if you have like 10 clusters, right? So it's significant, yeah, it's a significant amount of money. But also you are getting more behind, right? It's going to be more difficult to then, after 2 years, upgrade. Um, it's easier now to upgrade a Kubernetes cluster. In the past, it was actually quite difficult because there would be so many new things that would come out, new technologies. Um, like new images that you have to deploy on your Kubernetes cluster that you first have to upgrade, and then new APIs would change. So
Yeah.
it wasn't that easy to upgrade. Now it's easier, but still it's quite, like, just like I said, it's quite labor intensive to follow it, to upgrade it. So if you have a look here, here's the kind of standard support pricing, extended support pricing. So you start with 1.23, for example. That's where extended support starts. Yeah. So now we are here somewhere January, March 2024. You are in extended support, right? But if you wait until September 2024, right? Look, there's already 1, 2, 3, 4, 5, 6 other versions.
Yeah.
You know?
That's a crazy thing about Kubernetes. In like, it's good that they have such a like fast release schedule, but like to keep up with this,
It used to
like,
be 4 releases per
yeah,
year.
exactly.
So they changed even to 3 now, because now it's getting more mature. Or already a couple of years ago, it got more mature, and they stopped doing 4 releases. But yeah, I think when we go to a company and they ask, should I run Kubernetes or ECS or something else, right? I remember the first time this really came up, 2017 maybe, like
Yes.
7 years ago. Amazon EKS was not released yet, I remember. And then we were like, how should we run containers in production for a long time, stable? If you don't need all these features that Kubernetes is offering, then do you need Kubernetes, right? Do you need to start hiring people to just maintain your cluster, provide support to developers, like platform engineers that make sure that you have some kind of deployment platform? Do you need that if you're a small company, right? If you're
Exactly.
not an enterprise. So I think the first question you have to ask yourself always, like, great, we have extended support. We can run a Kubernetes cluster for 2 years now, more than 2 years. But do you need all these features, right? And what after these 2 years, what is the plan then? You're going to launch a new cluster and then migrate everything to make sure that you don't have to follow the whole upgrade path, or kind of what is the plan, right? Because if you don't need the features that Kubernetes is offering, if you just want to deploy containers, right, and you need scalability, immutable containers, all
Deployment,
these other
bells and whistles. Yeah, definitely.
all these other things, all these other features, capabilities that are also in other products,
Yeah.
then do you need Kubernetes, right? For enterprises, I would say it's a completely different story, right? Because if you have the team, if you can hire the people, you build yourself a Kubernetes team, you can provide capabilities to different teams, they can scale it, you can have like a deployment flow. Okay, that's a different story. But the majority of people that are adopting Kubernetes now, right? Smaller companies, mid-sized companies, maybe not even technology companies. Do they really need such technology that has 3 releases a year, that has more and more capabilities? Do you need those capabilities in the platform? Isn't there something else, right? Because Kubernetes is not an AWS product either, right? So if you want to stay within the AWS ecosystem, you would kind of tend to run ECS rather than the Kubernetes. It's like thinking about, should you run Kafka or Kinesis? Kinesis is something that AWS built. Kafka is some external company that they kind of have managed services for that software. Do you run Mongo? Do you run DynamoDB? And I think if you don't have a team supporting this, or you don't have the capacity, the engineers to hire them and to support this specific technology, it might actually be easier to look for within the AWS ecosystem for the products that AWS built themselves, like ECS, and then run on those, because then AWS will take a lot of management away from you. Less features, I agree, less features, definitely. But then you need to first make a business case. Do you need those features? What features do you need? What are you looking for, right? And I think that's often missing, that people they go straight to Kubernetes because that's what they read
Yeah,
on Hacker
exactly.
News.
Yeah, the size on
Or on-
Twitter, we need to do Kubernetes. Like either way, like I've been in that similar situation in the past as well when I used to work for a company based in San Francisco. And basically it was like, we need to do Kubernetes. And then you try to work your way back because I was a big advocate already for ECS back then. And it's like, basically what we do is schedule containers, right? Like keep a container running. If it dies, spin up a new one. If it fails over to another region, whatever, all like things that come out of the box in ECS. And basically it also like there's a bit of work in creating the ECS task definition and stuff like that. But it's nothing like in comparison to Helm charts and all that stuff. Yeah. Also, there wasn't a managed version of Kubernetes, so it would have gone from um, like a managed ECS solution to unmanaged Kubernetes running on like EC2 machines, managing Kubernetes themselves. So it was a big difference in opinions there. And it was like, yeah, we need to do Kubernetes to support our growth. And I'm like, but like, what does one thing to do with another? Now, in recent months, you see a lot of people coming back from that opinion and see like, whoa, this is so overkill. Because don't forget, this service that we're now discussing is already a managed service. So it's not like
yes.
that we're discussing to self-host it and try to follow up on the release schedule. This is already all the work you have to put extra into it to just run a managed service, which is quite crazy, right? If there's obviously feature set is different, but like in, can I say 95% of the use cases, it's like to run a container. You
Yeah,
do not use
I
like
definitely
Kubernetes
agree.
operators or something like that. Obviously, we worked in companies before where they actually used like the Kubernetes operators to enrich like transactional data and stuff like that, which all makes sense if you're going to use that. But like in the majority, it's just like um, obviously it is an interesting technology, like we said in the previous episode when we were discussing AWS Athena, like that you can use it for scheduling Spark jobs. So that's like a super valid use case if you're more familiar in doing it that way. But to the
Because indeed,
majority,
Spark has support for Kubernetes.
yeah,
Um, we were looking at this a couple of years ago, and there was no support for ECS. There was really a lot of support for Kubernetes because it's more a generic solution. So if you want to run Spark jobs, yeah,
yeah,
Kubernetes Spark operator, easy to run a Spark job on a Kubernetes cluster. I would rather run on a Kubernetes cluster than on a Hadoop cluster because Hadoop is then another
yeah,
technology that you don't really want to touch
yeah, that's a different
nowadays,
story. Yeah,
right?
not even
But
with a 2 foot pole, like
yeah,
like stay away from it. Yeah, yeah,
you said something interesting, right? Like in the recent months, maybe the last year, we are seeing indeed that people are coming back from you shouldn't really run Kubernetes. And I find it strange that it took so long, right?
yeah,
Because
yeah,
we
definitely.
started in 2017 and we're like, why would you run it? Why would you go through this? And
Yeah.
then you had the API changes, right? Because it starts with V1 beta 1, V1 beta 2, then it starts. Oh yeah, now it's stable, and we change
Yeah.
something in the YAML definition. Now you have to migrate all these objects. And then we're like, yeah, but why do you want to go through all this, right? The big benefit of uh, running on AWS is just that the API stays stable, right?
Yeah,
And I
exactly.
don't want to say that AWS has like always the best product or something like that, or you should always go to AWS products. You should just kind of write a business case first,
Hmm.
make sure that you know that the technology that you're going to adopt fits what you need and that it's maintainable, that is manageable over time, over the next couple of years. And even I think, because I'm sure that people say, you guys, you're just too focused on ALS. It's always ALS solutions. But do you need to run containers, right? Is there a use case to run containers? I know
Exactly.
it's easy, you can package it, but you know, are you running microservices? Do you need to run microservices? Does there need to be communication between different services? Maybe it's easier to run a monolith. If you run a monolith, do you still need containers?
Yeah.
Maybe yes, maybe no. I think, in the next couple of years, maybe people will come back and say, okay, we did all this container stuff and it's great to package. But I could just package this in a like an AMI, a VM, one machine, and I will just
Yeah.
package it once, with Packer, just like we used to do,
Yeah.
So
And Ansible playbooks and all that fun
yeah,
stuff that we used to do in the past. Yeah, yeah.
you know, it's great to run on AWS, and
Yeah,
AWS can offer you a lot of capabilities. Really, like you can get started easily, but you also see that a lot of people are also at some point moving away from cloud because they're saying, okay, I'm a small company. AWS is very expensive, and
yeah.
I think I see that now a lot with LLMs, right? You
Hmm.
want to run an LLM, you want GPU machines, well,
True.
AWS super expensive, right? So if you
Yeah,
don't have credits, you should then start looking at different solutions, and I think the same with just compute, right? You want to run an app.
yeah.
Okay, you start at, I want to run Kubernetes. Okay, but do you need Kubernetes? Okay, what's the alternative? ECS. Okay, but do you need ECS? Okay, Docker. But do you need Docker, right?
Yeah, yeah.
So you should actually, because we all have these abstractions, right? Kubernetes is on top of many things already, right? Because
Yeah,
it's like you have the physical machine, but then you have the hypervisor, and then you have
yeah,
the kernel, the kernel isolation Docker, right? Or container D or whatever you're using now. And then you have the orchestrator, right? So do you need all these layers, right? Because you are also paying for all these layers still, right? So
absolutely. But I think it also came from the past. That it was like kind of a promise that if you run and write things, and especially that was told to managers that when people want to try to experiment with Kubernetes and stuff like that, when we do it this way, we can run on any cloud provider out
yeah,
of the box
yeah,
immediately.
yeah.
It's cloud native. When we do it this, then obviously we can't have any names here or whatever, but we work with companies that were so focused on building one fits all solution instead of like, if you look at ECS Fargate alternatives, like you have Google Cloud Run and Oracle, you have OCI, you have container instances, the same on Azure. Like they all have like a Kubernetes alternative that just runs a container. Period. That is.
But what is more interesting is that their Kubernetes offering is also different,
Yeah, yeah,
right?
yeah.
So you can build for Kubernetes on AWS. Doesn't mean it exactly translates to Kubernetes on
No,
Azure because
no,
Azure has their own
no. But that was the
integrations,
assumption a
right?
lot of people
Yeah, it
made.
was an assumption, right?
but
But
but it's not.
there's not.
Yeah.
If you build something like, I'm looking for an example. Okay, you need injection of environment variables, right? You have environment variables, you have secrets, injection of secrets. But yeah, then you use the secret store, parameter store. It's one specific controller. But now you're going to run on a different Kubernetes cluster. But you don't have that. You don't have the parameter store there. I'm sure there are now like also controls that abstract that. But often
Again.
what, again, the abstraction of abstraction,
Exactly.
right? But often you build something specifically for Kubernetes on AWS, and then you still have to move it anyway. So it's completely a myth that you can build something for one cloud provider
Yeah,
then
but
just
then you
transfer it
have
to another one.
HashiCorp, and then you will install console, and then you install this and
Right,
that and this
right.
and that,
But
just to
then
be able,
console you
for
have to
the
maintain,
sake, exactly, for the
Yeah.
sake of running containers. And I think there was a tweet of Kelsey Hightower as well, who was a big Kubernetes advocate, who was like, it was recently, I don't know where it is exactly, but can edit it in later on or whatever. But it was like, yeah, maybe we went a bit overboard on what we're trying to achieve with this technology, which certainly makes sense because it's at the end of the day, it's just like you want to have a pipeline, developer creates code, business value, pushes it, and period. Like, and the most efficient way of like developer code reaching the actual end user that generates money, the steps between there, how it's run, like the end user doesn't care, right? Like, obviously, as long as it's stable and it's durable, and that's something that I have the feeling lately we don't have to advocate that solution to keep it simple as much as we used to do when cloud native was like hotter, I guess. Like I have the feeling that people like, maybe it's also the economic climate, is there less money, so people are trying to do it as efficient as possible. But yeah, it seems that that's, yeah, people are coming back from that. Like, oh, it's just easier to, for example, we're running ECS Fargate, a container. We have to move to to another cloud provider, just use the alternative of Google Cloud Run, for example, instead of like trying to build this one fit solution, like one fits all solution. It just doesn't work. But that was the promise that they made.
I also think that maybe you also oversee. We are thinking of the developer. Okay, the developer writes code, commits it to Git, right? And then you have, let's say, a Git. Let's say you have a Git. Yes, you are using GitHub. You have a GitHub action. Should the developer be exposed to anything more than the GitHub action saying it is deployed?
Yeah,
right.
This is the URL. Have fun with
this
it.
This is the URL. Exactly.
Yeah.
Now it's deployed, right? Okay. You can do fancy things because then it's like, oh, I want to have this PR on a separate like environment, but then it gets complicated. But like just to keep it simple, small company, medium company, the developer codes something, he pushes the code, it ends up in the dev environment, the UAT environment, the production environment. It doesn't need to be exposed to Kubernetes, even if you have Kubernetes. It just needs to see kind of it's deployed. And I think what also happens sometimes is that if a developer knows and is empowered to test a lot locally with very well-written tests, then he also doesn't need to be testing a lot in those other environments, those kind of live environments, dev, UAT, prod, and that's often what is missing sometimes when we look at how developers are writing code, is like, okay, now you have all these third-party services, right? So you have a third-party API, and then you have the API key, and the API key is in the dev environment. So I first need to push my code to be able to test this API call to this third party. But then it's like, why are you first pushing your code on a platform to test it? Yeah. You should already have tested locally on your local machine. But then they say, I don't have the API key. I cannot test it. Yes, but you should mock all your third-party APIs. Make sure that the tests that you run local and in your GitHub Actions has everything mocked, every third-party call mocked, so that you can independently, your software, test against all these entry points, all these API calls. It's often REST APIs, so that you're 100% sure that if the server acts as you think you are, that it gives you that your app at least gives the correct answer, interacts with it correctly. Yeah,
like just keep the feedback loop as small as
exactly possible. Exactly. When you have a discussion with developers, like, oh, but I need to push my code because I need to test something, and it needs to go very quick, and yeah, my feedback loop will be long if my deployment takes long, right? Then there's something wrong, I think.
Yeah, but which is absolutely true, right? Like, but if you look at wasted time, basically because of that, it's crazy, in my opinion. Obviously, you need to test it more thoroughly throughout the deployment phase, but that's something
of course.
A different stage, right? Right? I know that's also an interesting point, and yeah, sometimes you even see like that they have to do then they do the testing in Git, for example, and it's like, I think how long was it? I think it was
when they use the real API calls.
When they used the real API calls, it was a company that we help optimize. And
it's not only one company. I've seen multiple times.
Exactly. But what I was referring to was the company where we actually also helped them solve this, and it was like a feedback loop of 2.5 hours. And it's not like in the 1900s, it was fairly recently, and they were like relatively okay with it. They didn't see the issue, and I'm like, come on, like. But yeah.
So if you test with real APIs, and of course they are rate limited, and you want to test like 1,000 calls, well, it's going to take a long time to execute those 1,000 calls during your integration test, during your regression test, unit test, and so on. And that's also the problem. And that's why mocking is so important, right? You should kind of write multiple HTTP servers with a REST interface that you can connect to, that give real data that you just copy paste as test data into these services, just so that you can in 1 minute, less than 1 minute, test a lot of things with those other third-party APIs, so that you're 100% sure that your code is at least working.
Yeah, absolutely, absolutely. And to maybe that's something we can discuss in next podcast as well, is like how we can achieve that mocking and then go into deeper detail about that, so we don't like divert too much from the Kubernetes subject here. But it's a really, really good point. Another thing that I want to mention is that um, obviously we are also like we're a consultancy company. Like for us it would be even easier to just sell Kubernetes, right? Because you're just certain that you can sell 1 to 2 full-time employees just to manage a cluster. But in the end you see that it doesn't generate you any if the use case isn't there. Small star remark. um, um, that it just takes so much time to just run things. And if you see how many clients that we can serve with our company, like um, the majority of our clientele doesn't even have a full cloud engineer. Like it's like partially. And if you see how many environments and how many services that we can maintain that way, just because we use the correct technology is a bit big of a a dirty word in my opinion, because like it's opinionated what's the correct one and what's not. But if you just look at the use case and how we pull that into our service offering, and how many clients that we can serve happily, like also that were really small in the beginning and are now much bigger and still have that same deployment strategy, deployment, and how much time did we spend actually maintaining ECS, for example? None, nothing. Like, and it's also not important, right?
And I also think that because back in the day, ECS didn't have a lot of capabilities, right? But what we did at that point was we can choose between Kubernetes and we have to follow their release cycle, or ECS, and we're missing a few capabilities. So we actually wrote some custom code, right?
Yep.
Just like you would think of a controller in Kubernetes, but we kind of wrote a controller for ECS to add those capabilities. And then, okay, there is some work in maintaining this controller, but you would have to maintain a Kubernetes controller as well. So because people also write Kubernetes controllers, right? So you say, okay, I'll write a controller for ECS. It's just gonna run on ECS. I'm gonna use the AWS API to add some capabilities here,
For
and
sure.
then you can run it for 5-10 years and barely have to touch it, right?
Yeah,
And
yeah,
I think
exactly.
that's the if you look at our first ECS deployments, right? They're still running.
Yeah.
Like API hasn't changed, and we are now what 5 to 10 years later. Okay, maybe that's a stretch. That's a stretch.
That's a
Seven,
stretch, I think.
seven,
Yeah, yeah,
7 to 8 years
yeah,
later,
yeah,
we
yeah,
have
yeah.
ECS services that we didn't touch much. I mean, of course, we did updates and there's more stuff, but I mean, yeah, it's just so much less work if you don't need capabilities. If you need capabilities, okay, right?
Yeah, yeah,
If you need
definitely.
it, then you
Makes
need to
total
have a
sense.
team, and then you
Yeah,
hire some people, at least more than one, because it can go. I mean, you need to support maybe 24/7, and then you maybe need to write some code in a controller, and then you have some YAML definitions, and then maybe one last thing I want to talk about. And we should maybe talk about it also in a separate podcast, but you know that now people are using. Okay, sorry. We started with what? Ansible, right? And then there was Terraform,
yeah,
right? And then CloudFormation, Terraform CloudFormation, and then CDK came, right? Now you can just write your code in Python or Node, and then you have. Why don't you just write a YAML definition in Kubernetes to provision your infrastructure, right?
yeah.
I find that so crazy. I mean, okay, there is a use case for it, right? If you are using Kubernetes but then I see small companies saying like, oh, I don't like Terraform, I like CloudFormation. CDK, no, not really. But I have this Kubernetes cluster here, and I like the YAML definitions. Let me just write like my infrastructure, like my S3 buckets, my Kinesis streams, my whatever in a YAML definition, and then that will be executed, and then that will be provisioning my infrastructure. But okay, that all sounds fancy and interesting, and
Which it is,
it
but
works, it
yeah,
works.
yeah,
But
yeah, definitely.
if you just take one step back, okay, you have an abstraction of an abstraction of an abstraction of an abstraction, and you're like so deep in abstractions that is so crazy. I mean, okay, if you're an enterprise and you need a lot of abstractions so that one team can work on this and one team can work on this completely isolated, I understand, right?
Sure.
But smaller companies, when you just have a small IT team, I don't know if that's really the way to go. I would just rather try
it's
to reduce abstractions,
yeah, exactly.
like just what is the easiest way for us to deploy somewhere without, because then you have to okay, you have to learn how ALS works. You have to learn how Kubernetes works. But then you have to learn how this integration, how do I deploy provision infrastructure on ALS? What if something goes wrong there, right? And then they still have to learn all the ALS API calls, because what if something goes wrong? And then then I need to be able to roll back or understand if something goes wrong. Like, there's so many things to learn, and the scope is so broad of everything that you have to learn. Whereas, let's say that you would just use, I don't know, I'm just making fun of it now, AWS CLI to deploy something, right? There's one API call to learn. Okay,
Yeah.
it's not one API call, because often you need multiple API calls, but it's like something that is supposed to be simple, just creating some resources. Okay, Terraform is easy for that, for example. And even though Terraform became complicated over the years, right? Because now it also became a programming
Yeah,
language. Back in the day
exactly.
when we started, it was just like, you
Yeah.
just declare what you want. No programming language, no
And I'll
modules,
provision it for you
and
and
it will
make
provision
sure
it
the
for you,
state
right?
doesn't change. And yeah,
And
exactly.
I think a lot of companies need to be very close to that. I just kind of say, this is my HCL, right? My,
Yeah.
my code. And just by looking at the code, I can see what I'm provisioning.
Yeah.
And not like down 5 layers or up 5 layers, whatever,
Yeah, exactly.
And then if someone comes in that is new, and he needs months to be trained on
Yeah, yeah.
on how to deploy a resource on the cloud, right? And then people say now, cloud is actually so complicated, so complex,
I'm
right?
going back on prem.
We need training, we're doing everything wrong. It's super expensive, right?
Yeah.
And it's also because I think, I don't want to generalize, but I think a lot of people have been so down into head down into CDK, all the CDK projects we saw, like, there's people that quit their job over CDK projects, because
Hmm.
it's like
Not even one.
not even one, yeah. It's like it's not
No.
gonna. So
Yep.
we
But
should
it's
spend
all
less time on figuring out how CDK works, and more time like, how do we do cost efficient deployments? Like, what is in my AWS build? Why am I build so much, right? Because you are down in CDK, right? Trying to figure out how something works, and this resource and this resource. But at the end of the month, you suddenly have like 10, 20,000 more, or
hmm
paying to AWS. But where does it come from, And what decisions have you made that suddenly your bill goes up by so much, right? And if you down so many abstractions, you kind of forget sometimes, like, the most important thing. I have this resource. If I deploy this resource, or if I use this product on AWS, what is it going to cost me?
Yeah.
And is there another product that is maybe cheaper, right? Um, because it's so easy to spend so much money on AWS, and if you don't keep an eye on that, before
hmm
long, it's
Yeah.
like super, super expensive.
Well, and also to uh, like maybe like I don't want to generalize it here either, but like the majority of the CDK project, at least the ones I was involved in, the amount of time spent in CDK for just the sake of spending it in CDK, that it's been provisioned by CDK, and all the edge cases that then had to manually be covered, like what if the Kinesis table already exists? What if you want to change all that stuff? You know what I mean? Like, that's all been handled by Terraform, for example, or CloudFormation, or whatever. It doesn't really matter.
Well, in Terraform, it's like, let's say that let's say we create DynamoDB table,
Yeah,
right? You do Terraform apply, and then 3 seconds later it says it already exists.
yeah,
You want to import
exactly.
it, right? But with CDK, it's like, oh wait, first we're gonna transform it in CloudFormation code. Then it's gonna go into CloudFormation. We get a change set. Okay, now we have this change set. Now we're gonna run, and then it creates like 100 resources,
Yeah,
right? And
yeah.
then, oh, the 101st resource, oh, it
Roll
already
back.
exists. Oh, rollback. And
Yeah,
then it's
exactly.
like
Yeah.
1 hour later.
Yeah, exactly. Which
1 hour, yeah.
exactly was the yeah, and then
Yeah.
they were also
It's a
like so
feedback loop. It's a
heavily
feedback loop,
invested that it almost became like you're trying to convince people of another religion. You know what I mean? Like
Yeah.
like maybe you should just not do it this way. No, we invested so much time. We're going to continue this path, and then like, but that's more like an organizational problem. But nevertheless, it's sometimes. how much after that thing that you're trying to achieve in CDK is going to be run again after this one time that you all provisioned everything? How many, like, if you,
It's not multi-cloud either, right? So
no, exactly. It's like, yeah,
but there is a
that's also
use,
a
there's
valid point.
again, just like there's a use case for Kubernetes versus
Absolutely.
ECS, there's a use case for CDK.
Yeah.
Like you have one developer, or one developer within a big organization, and he needs to provision everything, the app and the infrastructure.
Yeah.
CDK is ideal for that because he can write his Python code and have an extra file. Where it doesn't make sense is that you have an operations team that will then pull all these repos, like all these lambdas, for example, all this code, and then it's going to build like this one huge CDK project. That's completely insane, and that's where it goes wrong.
Yeah, exactly. Yeah, and I've seen that multiple times already. But it's like you said, we also have seen good CDK projects,
Yeah.
basically. But that's also like, but it's most of the times they're not that really big, those projects. Especially if there's already a separate operations teams. In my opinion, it doesn't make much sense to still do it that way then. Like, obviously, you can see where the abstraction of the, like, not abstraction is the wrong word, but where the responsibility of the operations team, and because in some companies, operation team just provision you an AWS account and be like, have fun with it, buy and just enforces some controls and that's it. And then it can make sense. But like in the majority of the things, it's just like so much overhead for like you're just trying to have a DynamoDB table, an RDS, some Kinesis stuff, an S3 bucket, CloudFront formation, something, CloudFront distribution, something like that. And it's like, why do you just make it so complicated? There's tooling for that. And you will probably, once that's been running, you will be working on that software version and you will never touch it. And if you need to touch it, it's been so long since you touched it that it's integrated into your code that you need to revise and test everything again. Maybe there's some CDK changes. I don't know, like stuff like that. It's an interesting topic. Maybe you should move this to a different.
Yeah. But it actually, it's all related, right? Because
Yeah.
at some point you have to think, what of the infrastructure code that I'm writing is really like something for operations, and what
Mhm.
is something that is actually more on the developer side?
Yeah.
Because sometimes the developer needs to say, like, I need a new table in DynamoDB, I need a new Kinesis chart to make my app work. So some of this you still want to give to the developer, but some of it you don't want to give to the developer, like networking maybe, right? You just need to set it
Mhm.
up once for account controls. Maybe you want to block all the S3 public access within the account. So that's maybe more operations team,
Yeah.
right? So to then have one big solution, this is my Kubernetes solution, and then say, here, developers, here's a Kubernetes solution, right?
Do
Now
your thing.
learn how, yeah, do your thing. It's like you can do whatever you want. No, that's also wrong. So you kind of need to make a line somewhere, right? I know that's like you have DevOps, and I mean, you ideally you work together, right? DevOps, so Ops works with Dev. Ops provides a platform, but and Dev then and yeah, so Dev, the developers want to also create resources easily.
Yeah.
So there you just have to find a good balance, right? How do you make sure that you don't block the developer so that he can work, but maybe like how much does the developer know about AWS? Is it maybe better that you always still create everything, so then maybe you make sure that you do the provisioning. So there's no one solution for
No,
for
no,
for
definitely
for all
not.
the teams, right? But this is definitely something that you should kind of think about, right?
Yep.
What is really operations and what is close to the developer, and
Yep.
what are we going to provision in what's tooling, right? Because if you then say, oh, we're going to do everything in CDK because now we have learned how CDK works, everything in CDK, then it can get quite complex, right? Because
Mhm. Definitely. The
yeah,
rabbit holes are very, very deep.
yeah, yeah.
Like, and that's just like, yeah, in the end of the day, it doesn't bring you much business value, right? Like if it runs on
Yeah, the
whatever,
customer is
like,
never going to ask, did you run CDK? Because otherwise I will not become a customer.
exactly. Exactly. It's like I want to just use the
If you don't
product.
if you don't run Kubernetes, I'm not gonna sign up,
Yeah,
right?
yeah,
No,
yeah.
it's
No,
like nobody
exactly.
nobody sees this stuff, right?
No, no, no,
So
definitely. But there's a lot of opinions, and I think we will have like triggered a lot of opinions here as well. But
oh,
we'll see. We'll
we
see.
should have put a trigger warning somewhere.
Yeah, look, it is just like after seeing so many years of the technologies being used, um, maybe also to mention like how many students do you have on Udemy on your Kubernetes training? Just to
330,000 something over
exactly. So it's not that we're
8 years or
against
something.
this. So
Oh
maybe
yeah,
it's
no, of
also
course
good
not. Of
to
course not.
remark
Yeah.
it. Like,
Yeah. So
uh,
I started, I think it was 2016. I think it was 2016 I started
yeah,
Kubernetes training. And yeah, it was been massively popular. And also Terraform training, massively popular. Because so many people need to be trained on this technology because it's so complex, right?
yep.
So yeah, it's definitely a useful technology.
But it's also important to mention that we're not just like getting in the comments like, yeah, but you guys just don't use it ever, so you don't are not familiar with it or whatever. Just wanted to tackle
Yeah.
that comment already in
Yeah.
advance.
I think we try to just go to the customer, kind of forget everything that we know. I mean, and then
Not literally,
not literally, but let's see what the problem is and how can we solve the problem,
yeah,
right?
exactly,
And not just
exactly.
copy paste the Kubernetes solution or an ECS solution, but what is the most efficient way to solve the solution, right?
Yeah,
Like, what are we going to do? And then that's actually, if you go back and look how people in big companies work, right? Maybe not even technology teams. They will first open PowerPoint and say, we have a problem, or whiteboard. Even I think at Uber, they do this at Uber. Let's first try to solve this in a way to solve the problem without picking any technology,
yeah,
right?
yeah. What needs to
That's
be done?
what needs to be done,
Yeah.
right? Once we know what needs to be done, we can map this on a technology. We can
Yep.
see what technology is best. But first, we need to know what is the problem, how do we solve it? And not, I have a problem, technology X is a solution. No, that's not how it works.
No, exactly. Or there's a problem. I already have a technology. Yeah, but you don't know what the problem is. Doesn't matter.
Doesn't matter.
This
Yeah,
will
yeah,
solve it. Yeah. But
yeah.
also there was like what I noticed a lot about Kubernetes in the beginning was that it was a hot technology. It was being used by big companies. So if you were familiar with technology, like the chances of being hired by a bigger company would be better. And also it was like, yeah, I can put it on my resume. A lot of people were looking into skilled people. Like if you saw the salaries of people with those skills, like it was all like
But
a
that's
catalyst
still
of
today.
everything. Exactly. Yeah.
Today, that is still the case. So I read that if you go for an interview, cloud/DevOps, and you don't know Kubernetes,
Yeah.
even though they're not running Kubernetes, they will say you're not a
Yeah.
cloud/DevOps
Yeah.
person. I'm not
Yeah,
going to
yeah.
hire you
No,
because you
exactly.
don't know the Kubernetes. So if you are like a cloud engineer, DevOps engineer, something related, you probably have to learn
Yeah.
Kubernetes, even though you're not going to use it. But it's also good to know how it works, to know when not to use it, right? So
Exactly.
they kind of have maybe a point, but it's not because of that. It's just like we might be running Kubernetes, so we need to find someone with Kubernetes. So yeah, first skill you
Yeah.
have to learn. I think indeed, if you want to get hired by companies like Kubernetes and cloud, uh, just like even though they might not be using any of them, you
Yeah.
still these are the hot technologies of today. So you have to know them.
Yep.
Yeah.
But to circle back to the beginning of the podcast here, like just be aware of the release schedules as well.
Oh
It's
yeah.
gonna cost you a lot of money, and it can go like
Time.
become yeah, and take some time to
And
upgrade
and one
and
thing that we didn't maybe emphasize yet is who likes to upgrade a cluster. Tell me someone who really likes it, who likes to like go in and say, okay, now I need to do 3 releases for one cluster, and I have 9 more clusters that I need to do, and I hope
yeah,
that nothing will go wrong. And if
yeah,
something goes wrong, I will be sitting here for the whole night or the weekend.
yep,
And then there's another interesting thing that is that when very small companies that don't have the money to pay for all the environments just have one Kubernetes cluster.
yeah,
And then they're
and
like, oh,
run
the
everything
upgrade,
together. Yeah,
everything is in there. The upgrade button is here. How do we upgrade it? Well, one day I'll just click the button. Click.
but
Okay, the
but it's in
cluster
a
is
different
upgrading.
namespace. Like,
Yeah, it's a different
yeah.
namespace. Yeah,
So
and
it's
then
what's the problem?
all the services go down, and then you just
Yeah.
hope that everything comes back up.
Yeah. Yeah.
I mean, it
And
doesn't all go down because you have like these rolling updates
yeah,
and stuff
yeah,
like that. But I mean, it's just such a risk, that I wouldn't like to take
no,
personally.
no, no, no. If it was my company, I wouldn't take that risk. Obviously, because they chose the technology, they have the cost handicap already. So like that's why they can't run 3 clusters, because then it becomes like 3 times as expensive. So that's why they choose one, but then they try to push everything into that one. But
That's also
it's
something we haven't really said yet, right? Because you pick a technology on AWS or wherever, you're gonna have to multiply everything by maybe 3 for every environment that you have, right? So you say, okay, I have this end of life cluster, right? 50 cents more per hour. Okay, it's only 50 cents. But wait, I
Per
have three
hour.
environments. I have 3 environments per
Yeah.
hour that have to run
Yeah.
3 times, you know?
Yeah. There's
So it's yeah,
20 hours in a month, so it quite adds up, and a
700
month,
yeah,
like a
700
month flies
730, right?
by. Yeah, I think like in there could 720, 730. Yeah, what was
Yeah, 720 or 730. So you have to multiply by that, and for every environment, and for every cluster that you have,
Yeah,
right?
yeah.
So you better
Then you
if
can
you if you know,
hire a cluster upgrader. Like,
yeah, yeah. If you look at the blog article and you have the blue bar, so if you add all the extra time that you would run at 50 cents per hour more, right? How many classes what is the cutoff where you can actually hire someone like an intern? You can probably hire an intern already to
investment
upgrade.
round here, investment round here. Like, no, true. Absolutely makes sense. Absolutely makes sense. No, right. I think we discussed a lot of topics. We already covered
Yeah,
a lot of time as well. So I hope everybody enjoyed it. And I think we can conclude here. And I'll
yeah.
see you back on the next podcast. Thanks for listening and viewing.
All right,
Bye.
see ya.
Bye
Bye
bye.
bye.